Hello students, welcome to the subject of complex variable in partial differential equation. This is Dr. Ankit Acharya, and as you all know that in last lecture we discussed about case 2 for the function f of xy, that is equal to sin ax plus by or cos ax plus by. So in today's lecture we discuss about our case 3, how we can find particular integral for case 3. Case 3 means what? Suppose you have a polynomial x raised to n into y raised to n, where m and n both are integers, right? So rational integer algebraic function of x and y. So how we can find particular integral, that is our case 3, 1 upon f of d dash into f of xy. Okay, so in this case we expand f of d dash inverse. That means we know that 1 upon f of d dash, that means we can write f of d dash inverse, right? And we expand f of d dash inverse is an infinite series of ascending power of d and d dash using binomial theorem, and operate f of xy, operate on f of xy term by term. Okay, so this is our method to solve case 3, and for that you have to apply this two rule. Let me show you this two rule that you have to apply. We will use the following formula. As you all know that 1 upon 1 plus x can be written as 1 minus x plus x square minus x cube and so on. Okay, 1 upon 1 minus x, that is equal to 1 plus x square plus x cube and so on, right? But here instead of this x, we have some function of d and d dash. Okay, some function of f of d. I just write here f of d, but in your case f of d dash. Okay, here also f of d dash. Okay, so that's why instead of x, suppose you have a function f of d or f of d dash, can you apply this formula once again? So 1 upon 1 plus f of d, I can write 1 minus f of d plus f of d whole square minus f of d whole cube and so on. 1 upon 1 minus f of d, that can be written as 1 plus f of d plus f of d whole square plus f of d whole cube. Okay, either you have a function of f of d, either you have a function of f of d dash, or either you have a function of f of d dash. Okay, you can apply the same binomial theorem with the same manner. Now you have to remember some of the formula that you already know. Suppose you have a function like this, d into f of x. Now capital D into f of x means what? You have to differentiate f of x, f of xy. Okay, you have to differentiate f of xy with respect to x. So remember all this formula. Suppose you have d dash into f of xy, d dash into f of xy. That means what? Differentiate of f of xy with respect to y. Suppose you have a 1 upon d into f of xy. Okay, 1 upon d into f of xy means what? Integration f of xy with respect to x. Similar manner, 1 upon d dash into f of xy. So that means what? Integration of f of xy with respect to y. So I hope you remember this all formula, that d into f of xy, that means differentiation of f of xy with respect to x. Suppose d dash into f of xy, that means differentiation of f of xy with respect to y. Okay, suppose 1 upon d into f of xy, that means what? Differentiation integration of f of xy with respect to x, and 1 upon d dash into f of xy means what? Integration of f of xy with respect to y. Now suppose d square f of xy, that means you have to differentiate 2 times with respect to x. Suppose d dash square, that means you have to differentiate with respect to y 2 times. Similarly, suppose you have 1 upon d square and 1 upon d dash square, that means you have to integrate of f of xy with respect to x 2 times, and here you have to integrate of f of xy with respect to y 2 times. Okay, so just try to remember all this formula, because I will use all this formula which you already know. I hope you already know, because I use this all formula in this case. So let's solve our first example. Del cube z by del x cube minus del cube z by del y cube, that is equal to x cube by cube. Okay, so what is my f of d dash? First of all, what is my f of d dash? F of d dash is nothing but d cube minus d dash cube, that is equal to 0. Correct? Okay. And now the function of m, I can write m cube minus 1, that is equal to 0. Clear? And from this function, this is nothing but a cube minus b cube, and we know that factorization of a cube minus b cube, that is a minus b into a square plus ab plus b square. So that's why I can write m cube minus 1 in this form, m minus 1 into m square plus m plus 1, that is equal to 0. So roots are, directly I can write roots are 1. From this m square plus m plus 1, I have complex roots. So minus b is minus 1 plus or minus square root of b square minus 4ac. That means b square is what? 1 minus 4, a is 1, here also 1, okay, divided by 2a. So that's why roots are 1 minus 1 plus or minus, this is 1 minus 4, so minus 3, so square root of minus 3, I can write root 3i divided by 2, okay. So my first root is 1, second root is minus 1 plus root 3i divided by 2, and the third root is minus 1 minus root 3i divided by 2. So that's why I can write complementary function that is equal to f1 y plus x plus f2 y plus m2x. What is my m2? Second root is nothing but minus 1 plus root 3i divided by 2. So minus 1 plus root 3i divided by 2 into x, and plus, I can write plus f3 y plus minus 1 minus root 3i divided by 2 into x, okay. And now find particular integral. Okay, I want to find particular integral. So particular integral, as you all know, that 1 upon f of d dash, so 1 upon d cube minus d dash cube, and what is my function? Function is x cube y cube, okay, x cube y cube. So first of all, 1 upon d cube, that I have to take common because I need 1. In denominator, first term must be 1. So 1 upon d cube I can take as a common. So in denominator now I have 1 minus d dash cube upon d cube. Okay, I can write x cube y cube. Okay, try to understand very carefully. Now this equal to, I can write 1 upon d cube. Okay, now simplify this term. This is nothing but 1 upon 1 minus some function of d and d dash. Okay, so I can apply 1 upon 1 minus x formula. Okay, so that's why this equal to 1 plus d dash cube upon d cube plus d dash cube upon d cube square and so on. Operate function is x cube y cube. Okay, so now one by one I have to operate all this operator. So first of all, simple multiplication. First of all, 1 into x cube y cube, so that is x cube y cube. Then d dash cube upon d cube into x cube y cube. Now d dash cube means what? Differentiation of this function with respect to y 3 times. Okay, now the second term is, last term is d dash raised to 6 upon d raised to 6 into x cube y cube. But from this term, all the terms become 0 from this term, because this means what? D dash raised to 6 means differentiation of this function with respect to y 6 times, and we know that differentiation of y cube, okay, only up to third derivative we will get the value. From fourth derivative the values are 0, so that's why from this term all the terms become 0. So that's why 1 upon d cube x cube y cube plus, now one by one differentiation. So first I differentiation with respect to y first time, so d dash square upon d cube. Okay, differentiation of y cube, that is 3y square, so this is 3 x cube y square all other terms are as it is. Now once again 1 upon d cube, okay, x cube y cube plus, now once again differentiation with respect to y. So d dash upon d cube, I can write differentiation of y square with respect to y. So that is 6x cube y, 6x cube y. Okay. Now once again differentiation with respect to y. So all other terms are as it is. 1 upon d cube plus x cube y cube plus 6x cube upon d cube now. Okay. So 1 upon d cube into 6x cube. Now you have to integrate integration with respect to x, because here we have 1 upon d cube. All other terms are as it is. So x cube y cube plus 1 by 1 integration. So 1 upon d square integration of x cube. So that is x raised to 4 divided by 4. So now this is 3 by 2. Okay, I can write 3 by 2. Now this equal to 1 upon d cube x cube y cube as it is. Okay, now 1 upon d, again integration with respect to x. So that is x raised to 5 by 5, and in denominator we have already 2. So 3 by 10, I can write 3 by 10 x raised to 5. Okay, again integration with respect to x. So x cube y cube, 1 upon d cube x cube y cube plus, now this is x raised to 6 by 6. Okay, so 10 into 6, 10 into 6, that is 60, and in numerator we have 3. So I can write x raised to 6 by 20, because 3 by 60, so that can be written as 1 by 20. Now again the whole function, I have to integrate the whole function with respect to x 3 times, because outside the bracket I have 1 upon d cube. So I just write this term once again on the next page, so you can easily understand. Okay, 1 upon d cube x cube y cube x cube y cube plus, what is my last term, x raised to 6 by 20. So x raised to 6 by 20. Now integrate this term one by one. So first of all 1 upon d square, okay, x raised to 4 y cube divided by 4 plus x raised to 7, okay, divided by 7 into 20, so that is 140, right? Now again 1 upon d integration of x raised to 4, so that is x raised to 5 by 5, so x raised to 5 y cube upon 5 into 4, so that is 20 plus x raised to 8 divided by 8, but in denominator already we have 140, so 140 into 8, 1120, okay, and now again integration, final integration with respect to x. So that's why the final answer is x raised to 6 y cube divided by 20 into 6. Okay, so that is 120 plus x raised to 9 divided by 1120 into 9. So the final answer is 10080. So this is my particular integral for the function x cube y cube. Okay. So in today's lecture we discuss about case 3. Try to remember the case 3. For that you have to apply this formula, 1 upon 1 plus x or 1 upon 1 minus x. Okay, binomial formula, and term by term we have to apply all the operators. So in today's lecture we discuss about our case 3 for the polynomial x raised to m into y raised to n. So thank you.